Alright, today we'll be going over colligative properties. So, colligative properties are properties of the solvent will change when a solute is added. So, it's the properties of a solution as compared to a pure solvent. So, we know the boiling point of pure water is 100 degrees Celsius, and when salt is added, the boiling point should increase. And so these are colligative properties. So colligative actually means I think it means collection. So when you add stuff, when you have a collection of things, what happens to the properties? So evaporation, if we were to sketch the evaporation of water on a molecular level, you would have, it kind of looks like here, right? So you have your surface, and those surface molecules leave because there's less IMF holding it at the surface. The higher the temperature, the more of those molecules that leave. Okay. Now, if I added a solute, what would happen? What would happen to the rate of evaporation? Let's look at the next picture. So it's kind of hard to see, but you can see looks like blue and green. And so what happens is if you can imagine, the more surface area there is, the more likely that these particles can leave or evaporate. But if you kind of throw something in between, say this is a solute, well, what happens is there's not as much surface area, there's not as much area at the surface where the particles are able to escape. And so if it almost blocks that area, right? And so therefore, less of the water particles are able to leave or evaporate. And so it would actually require more energy to move these particles to the surface, and so the boiling point you would expect to increase. It would be harder to evaporate, so you'd be at a higher boiling point. What does this mean for vapor pressure? And so vapor pressure it's pressure due to vapor, right? So that's what it means. And so if you have water molecules that are leaving, so here's your your water line. As water molecules leave, these gas particles, these are vapor particles, right? They're gas particles. And so the pressure due to these particles So this is the vapor pressure is the pressure due to these gas particles that leave, right? And so what happens is if you have the more evaporation that occurs, the more gas particles, and therefore greater vapor pressure. But remember, we just said that evaporation is limited when you add solute. And so therefore, as you increase solute, you decrease vapor pressure. And actually, vapor pressure and boiling point are related. So when the boiling point, the definition of boiling point is actually when vapor pressure equals atmospheric pressure. So if you lower vapor pressure, you actually have to, what happens is atmospheric pressure is going to stay same. So if vapor pressure is lowered, you got to find some way to increase vapor pressure to match the atmospheric pressure, right? So what happens is you need more energy, and so your boiling point increases. So why is this? You can use this as engine coolant because you don't want engine coolant to boil quickly because that will lead to pressure in your radiator, and so you use like antifreeze, and so you actually want it actually works in two different ways. One way is on really hot days it doesn't boil quickly, and then the other way we're going to talk about, it actually lowers the freezing point, and so it's kind of a good mix, so to speak. All right, so for freezing, what does freezing look like? Well, freezing is when you go from a liquid, right? So you go from these particles that are moving to now particles that are stuck in what we call a crystal lattice, right? Okay, and the force that's holding them together is these are IMF forces, right? These are holding these molecular forces. Specifically in water, H2O, since you have hydrogen with oxygen, it's going to be a hydrogen bond. Now, what would happen if you add a solute? Well, if you add a solute, say for example, now you have this, and then let's say I put this red solute in between. What happens is the solute kind of gets in the way of these IMF forces to work. So there's these IMF forces here, they kind of get in the way, and so it actually takes longer. It takes longer for these to kind of settle between each other. And so what happens to the freezing point is it decreases. It requires even less energy, so you have to move even slower for these to come into contact, for your solvent to come into contact. So the freezing point would go down, and actually, so this is why if you add salt to the road before it snows or before it's going to be icy, what happens is you actually get lower the freezing point. And so let's say if the weather report says it's going to be 0 degrees Celsius, and so there might be ice on the road. If you throw salt on it, it lowers the freezing point of water. So at 0 degrees, water just remains liquid, and so you wouldn't have that ice, right? So what does this happen? What looks like this on the phase diagram? Well, if you remember, the addition of solute increases the boiling point and decreases the freezing point. So this is your freezing point would go this way, and then your boiling point would go this way. So it looks something like this, right? And so you can kind of tell it actually remains liquid longer. And in some cases, like, the coolant in your engine or water on the road, water is actually safer than having it as a solid, right? And so that's what it looks like on the phase diagram. So how could you, if you really wanted, like, let's say you really wanted to depress the freezing point, what could you do? Well, I think the most obvious is to add more solute. So increase the solute. But there's other ways of looking at it too. So some solutes will give you more bang for your buck. For example, sodium in water will dissociate into Na plus and Cl minus, right? Whereas magnesium chloride might go into magnesium. But what I want you to notice is that you'll get 2 chlorines. So the number of ions you get out of sodium chloride, you get 2 ions, 1 Na plus and 1 Cl minus. In this case, you get 3 ions. And so not only can you increase solute, but you can use a different solute where you have multiple ions, right? And so that would actually increase, because it's not what it is, it's just how many things are interfering with either the boiling point or the boiling point or the freezing point. So I've put 2 things on. There's homework on Google Classroom, and there's a quizzes posted as well.